Hello friends, today I am going to discuss about the CAM, the classification of CAM, types of followers. CAMs. A CAM is a rotating mechanical member which is used for transmitting a desired motion, either reciprocating or oscillating motion to a follower by means of the direct contact. Therefore, to get the continuous motion to the follower, there should be direct contact between the CAM and follower is essential. Now to get the motion to the follower, there are three components or the elements in a CAM mechanism. So one is a driver member, which is known as a CAM. Then the driven member is a follower, and to support the CAM and to guide the follower, there is a frame. CAMs are widely used in IC engines to operate the inlet and exhaust valves. So this is a CAM of an IC engine. CAM rotates and the follower reciprocates, and it operates this inlet and the exhaust valve of an IC engine. Regarding the classification of the CAMs are broadly classified into based on the shape of the CAM, follower movement, and based on the manner of the constraint of the follower. Based on the shape of the CAM, set may be the wedge CAM, disc CAM, spiral CAM, cylindrical, conjugate, globoidal, and the spherical. Based on follower movement, it may be the rise, return, rise, dwell, rise, return, dwell, dwell, rise, dwell, return, dwell. Based on the constant of the follower motion, follower, it may be the preloaded spring CAM, that is known to maintain the continuous contact between the follower and the CAM, and positive drive CAM and the gravity CAM. Let's discuss one by one. Wedge or the flat CAMs. A wedge CAM has a wedge in general which has a translational motion. The follower can either be translation or it may be the oscillating motion. A spring can be used to maintain the direct contact between the CAM and the follower. Then the second type of CAM is a disc or the radial CAM. So it is commonly used because of its simplicity and the compactness. It is formed on a disc or the plate. So a CAM in which the follower moves radially from the center of the rotation of the CAM is known as a radial or the disc CAM. This is the center of the CAM which rotates with respect to this. The spiral CAM. A spiral CAM is a face CAM, that is in the groove is cut in the face of the disc. The spiral groove consists of the teeth which meshes with the gear follower. This is a follower. The velocity of the follower is proportional to the radial distance of the groove from the axis of the CAM. Then the cylindrical or the drum CAM. So in this, a groove is cut on the circumference of the cylinder which varies along the axis of the rotation. The follower rides in the groove which gives its reciprocating motion along the axis of the rotation. This is the CAM, that is cylinder, and the groove is cut here, and follower will reciprocates. Then the conjugate CAM. A conjugate CAM is a double disc CAM that consists of two discs, the disc 1 and the disc 2, and there is two rollers in a follower which oscillates. Then globoidal CAM, it is similar to the cylindrical CAM, but the difference is it has two types of surfaces. One is convex and it may be the concave. A circumferential contour is cut on the surface of the rotation of the CAM which impact the follower to oscillates. The spherical CAM, in the follower oscillates about the axis perpendicular to the CAM, rotation of the CAM. So that is, it is a sphere. A sphere, in the sphere, the groove is cut and the follower will guide or follow this groove. So now to get the oscillatory motion of the follower. Then second type of classification, the CAM is based on the follower movement. So it may be dwell, rise, then the return. A dwell is the zero displacement or the absence of motion of the follower during the motion of the cam. That is, as the cam rotates, there is no displacement of the follower. According to the follower movement, the cam are classified into rise, return, rise. That is, this is in this figure. So you can see there is a rise, return, then rise, etc. It continues. Then dwell, rise, return, dwell. That is, initially at the beginning there is a dwell. There is no motion of the follower. Then it will rise, then return to the position. Then once again dwell. Then once again rise. It continues. Dwell, rise, dwell, return, dwell. So it is commonly used, or most commonly used type of cam. Initially there is a dwell period, then it will rise, and once again in between there is a dwell and the return. Then according to the type of constraint of the follower, that is to maintain the continuous contact between the follower and the cam, some mechanism is used. So based on this, these are classified into preloaded cam, preloaded spring cam, positive drive cam, and the gravity cam. So in the preloaded spring cam, the compression spring is used to maintain the contact between the cam and the follower. Like this, in this figure you can see, in this simulation you can see there is a spring, a compression spring, to maintain the contact between the cam and the follower. Positive drive cam. So in this type, constant touch between the cam and the follower is maintained by roller follower operating in the groove of a cam. That is like this in the spiral cam or the spherical cam. Yes, there is a groove and it will follow, the follower will follow the groove. That should be the mechanical motion. The gravity cam, so in the rise of the cam is achieved by the rising the surface of the cam, and the return by the force of the gravity. Because of the gravitational force, it will move. It will follow the follower shape. Then the classification followers are broadly classified based on the shape, based on the movement, and according to the location of the line of movement. So based on the shape, it may be knife edge follower, flat face follower, roller follower, and mushroom follower. According to the movement, it may be the reciprocating follower and the oscillating follower. And so based on the location line of movement, it may be inline, that is the radial follower, or the offset follower. Let's discuss one by one. According to the shape of the follower, it may be classified into knife edge follower. The shape of so that is in the figure 1. So this figure, so the knife edge follower, the contact end of the follower has a sharp knife edge. So these types of followers are rarely used because of there is excessive wear takes place because of the small contact area. Then roller follower is widely used follower. It has a cylindrical roller, so it's free to rotate about a pin joint. So the pure rolling action takes place, but in high speeds there may be sliding also occurs. So it may increase the wear rate of the cam and the follower. Then the flat faced follower. The flat faced follower, here the contacting end of the follower is perfectly flat. The thrust at the bearing exerted is less as compared to this roller of the knife edge follower. So the last one is the spherical or the mushroom follower. It has a in the flat face follower, high surface stress are produced. To minimize this, so it is machined in the spherical shape to reduce the thrust on the follower. Then according to the movement of the follower, it may be classified into reciprocating follower. So in this type of cam rotates and the follower reciprocates. That is so commonly used reciprocating type of follower. Then the oscillating, and then the follower is pivoted at a point and the frame oscillates as a cam makes rotary motion. As a cam rotates, it will oscillate. The follower will oscillate, like in the spherical cam. Last classification based on the location of the line of movement. According to the line of movement, it may be the radial or the inline follower. So when the motion of the follower is along with the axis passing through the center of the cam, it is known as a radial follower. That is, here the center of the cam and the axis of the follower are in line. Whereas, so when the motion of the follower is along an axis away from the axis of the center of the cam, that is, there is offset, it is called the offset follower. This is about the cam, the classification of the cam and the classification follower. Thank you.